Welcome to 7th grade math. That's your homework that was due today. We're going to solve equations using models. Shows us cups and counters. So the variable for cups and counters is a cup. Integer 1 is a positive, and integer -1 is a negative or red circle. Algebra tiles, we have a green X, we have a tannish 1, and then we have a red rectangular -1. In Chapter 2, you use counters to add, subtract, multiply, and divide integers. Integers can also be modeled using algebra tiles. The table shows how these two types of models are related. You can use either type of model to solve equations. Activity: solve x plus 2 equals 5 using cups and counters or a drawing. There's a cup, that's going to be x. There's two positive counters, that's going to be plus 2 equals 5 positive counters, 2, 4, 5. So we modeled the equation. There's our cup, there's our 2, there's our 5. Remove the same number of counters from each side of the mat until the cup is by itself on one side. So if we take one away there, take one away there, and then we're going to take another one from the left side and another one from the right side. Minus 2, x plus 0 equals 3. So x equals 3. Since 3 plus 2 equals 5, the solution is correct. Check your progress. Solve x plus 4 equals 4. So we have the cup, which equals x, or represents x. We have the 4 counters, and then it equals 4. So if we take one away from each side, and take another away from each side, then another away from each side, and another away from each side, we get x plus 4 equals 4, x plus 4 minus 4 equals 4 minus 4, because if we take 4 away from the left side, we have to take 4 away from the right side. So x plus 0 equals 0, therefore x equals 0. So if we solve 5 equals x plus 4, there's our counters, 5, there's x, and then we have 4 counters. And remember, our goal is to get x all by itself on one side of the equation. So in order to do that, we'll start taking a counter away from each side one at a time. And we get, for the equation, 5 equals x plus 4. So we're going to take 4 away from each side, as you just saw with the counters. So 5 minus 4 equals x plus 4 minus 4. So 5 minus 4 is 1. 4 minus 4 is 0. So we get 1 equals x plus 0. And if we simplify that, it's 1 equals x. Solve 4 equals 1 plus x. So 4 counters, 1 counter, and the cup represents x. So if we take one counter away from each side so that we get x all by itself, 4 equals 1 plus x. We're going to take one away from each side, so 4 minus 1 equals 1 minus 1 plus x. 4 minus 1 is 3. 1 minus 1 is 0. So we get 3 equals 0 plus x, or 3 equals x. Solve 2 equals 2 plus x. So we have the 2. We have the 2 plus x. And if we take a counter away from each side, one at a time, until we have x all by itself, or the cup all by itself, we get 2 equals 2 plus x. In order to get the x by itself, we have to subtract 2. So we get 2 minus 2 equals 2 minus 2 plus x. 2 minus 2 is 0. 2 minus 2 is 0. We get 0 equals 0 plus x, or 0 equals x. A zero pair, a number paired with its opposite. And the example of opposites you might recall are 2 and negative 2. They have the number on the opposite side of 0. So 2 and negative 2 each have an absolute value of 2, so they are opposites. You can add or subtract a zero pair from either side of an equation without changing its value, because the value of a zero pair is 0. Now, the one thing I'll add here is you have to, if I subtract 2 from the left side of the equation, I have to subtract 2 from the right side of the equation to keep it in balance or equal. Solve x plus 2 equals negative 1 using models. So model the equation. We have x plus 2 equals negative 1. And we are using algebraic tiles. So add 2 negative tiles to the left side and 2 negatives to the right side. And we're doing that because the goal is to get x by itself. In order to get rid of those 2 positive tiles, we have to add 2 negative tiles so that they zero out. And then you'll see that by x plus 2 positive tiles plus 2 negative tiles equals 1 negative tile plus 2 negative tiles. And if we remove all the zero pairs from the left side, so there's one gone, and there's another gone. There are 3 negative tiles on the right side, and there's no negative pairs to remove. Therefore, x equals negative 3. Since negative 3 plus 2 equals negative 1, the solution is correct. And all we did there was we substituted the solution of negative 3 in for x, and we got negative 3 plus 2 equals negative 1. So mathematically, x plus 2 equals negative 1. If we subtract 2 from each side, or add 2 negative tiles, we get x plus 0 equals negative 3, and x equals negative 3. Check your understanding. Solve negative 2 equals x plus 1 using models. So we're going to use algebraic tiles. Again, we have 2 negative 1 tiles, or 2 integers. 2 tiles represent negative 1 each. So we have negative 2 equals x plus 1. So if we add 1 negative tile to the left side and 1 negative tile to the right side, and we're doing that because if we add 1 to the right side, we have a zero pair, and that will get x all by itself. So now we're going to, whatever we do to one side, we have to do the other side to keep it in balance. So we get, on the left side, we get negative 2 plus negative 1. And on the right side, we get x plus 1 plus a negative 1. And now if we remove the zero pairs from the right side, we get 3 negative tiles remain on the left side. So therefore, x equals negative 3. And since negative 2 equals negative 3 plus 1, the solution is correct. And again, all we did was add, we substituted negative 3 for x, and we solved the original equation, which was x plus 1 equals negative 2. Substitute negative 3 in, so it's negative 3 plus 1 equals negative 2. So if we solve this mathematically, negative 2 equals x plus 1. We need to get x all by itself, so we're going to take 1 away from both sides, or add a negative integer to each side. Then we get negative 3 equals x plus 0, and negative 3 equals x. Solve x minus 3 equals negative 2 using models. So we'll use algebraic tiles again. There's our x, and we have negative 3. and we have equals -2. So we have x minus 3 equals -2. So we're going to add 3 positive tiles to the left side so that we can get x all by itself. And whatever we do to the left side, we have to do to the right. So we're going to add 3 positive tiles to the right as well. So there's our 3 on the left. And as you can see, that's going to create 3 0 pairs, which will get x by itself. And we're going to add 3 to the right, which hopefully you see is going to give us 2 0 pairs. So x minus 3 plus 3 equals -2 plus 3. Remove all the 0 pairs from the left side. 1, 2, 3. So now there's nothing left there. And then we're going to remove all 0 pairs from the right side. 1, 2. And that's going to leave us with 1 positive integer. And therefore x equals 1. And since 1 plus -3 equals -2, the solution is correct. So mathematically, if we just go through this again, x minus 3 equals -2. We're going to add 3 to both sides so that we can get x by itself. We get x plus 0 equals 1, and x equals 1. So solve x minus 1 equals -3. Here's our x, and minus 1, and then we have equals -3. Add 1 positive tile to the left side and 1 positive tile to the right side. Hopefully you can see that we have a 0 pair on the left side, which is going to get x by itself. And getting rid of that -1 on the left has created a 0 pair on the right. So if we have x minus 1 plus 1 equals -3 plus 1, remove all of the 0 pairs from the left side, remove all of the 0 pairs from the right side. There are 2 negative tiles on the right side, therefore x equals -2. And if we plug in -2 for x, we get -2 plus a -1 equals a -3. So the solution is correct. If we look at it mathematically, x minus 1 equals -3. We're going to add 1 to each side to get x all by itself. So x plus 0 equals -2. X equals -2. Solve 4 equals x minus 2 using models. So we have 4 tiles on the left, and we have x and 2 negative tiles. So add 2 positive tiles to the right and 2 positive tiles to the left. And there's a 2 on the right and the 2 on the left. And that gives us 4 plus 2 equals x minus 2 plus 2. Remove all 0 pairs from the right. Both of those are gone. That does get x all by itself. Therefore, x equals 6. Since 4 equals 6 minus 2, the solution is correct. And if we just solve this mathematically, we have 4 equals x minus 2, and we add 2 to both sides so that we get x by itself, we get 6 equals x minus 0, or 6 equals x. Analyze the results. Explain how to solve each equation using models or a drawing. So we have a cup that represents x plus 1 counter equals 3 counters. So we have x plus 1 equals 3. If we remove 1 counter from each side of the equation, we get x plus 0 equals 2, or x equals 2. Explain how to solve each equation using models or drawing. So we have x plus 3 equals 2. It's represented both in an algebraic equation and by algebraic tiles. So if we add 3 negative tiles to each side of the equation, we just have 3 on each side that we just added. So -3, -3, and let's remove the 0 pairs. 1, 2. So x is all by itself. There are no 0 pairs on the right. So we end up with x plus 0 equals -5, or x equals -5. Analyze the results, make a conjecture, write a rule that you can use to solve an equation like x plus 3 equals 2 without using models or a drawing. So if a number is added to the variable, subtract that number from both sides. So in this case, x plus 3 equals 2. It's added, so we need to subtract that number, which is 3, from both sides so that we can get 0 by x by itself. So if we have x plus 3 equals 2, x plus 3 minus 3 equals 2 minus 3, and hopefully you remember that gives us 3 0 pairs on the left and 2 0 pairs on the right. So we get x plus 0 equals -1, or x equals -1. And if we check our solution by plugging in -1 for x, we get -1 plus 3 equals 2. So that is correct. And if a number is subtracting from the variable, add that number to both sides. So x minus 3 equals 2, so that's a subtraction problem. So to get x all by itself, we have to add 3 to the left, which means we'll have to add 3 to the right. So we get x minus 3 plus 3 equals 2 plus 3. And if we do the math, -3 plus 3 equals 0, and 2 plus 3 equals 5. So we get x equals 5. And if we check by plugging 5 in for x into our original equation, we get 5 minus 3 equals 2. So that is also correct. Tonight's homework, you're welcome. All right, have a great night, and I will see you in class.